now that we've made it work, there are a few more things I would like to show you. Um, let's assume, for instance, that apart from the fact that male dogs and female dogs have their own way to pee, there are also a couple things that they are doing in common when they need to pee. Let me show you how that works. We go to dog base and we can create a public virtual method P. Okay, the virtual keyword tells the inheriting class, the derived class, that it can do something, but you will probably, most likely actually, want to override that with your own code in the derived class. You have a method, we have a method jump on couch here. The fact that we have this method tells the deriving class, don't worry about that one, I got this. But when a method is marked with virtual, it tells the deriving class, I can do this for you, but you'll want to add some of your own stuff to it. Let's show you how that works. Let's insert some code here. And that one needs to pee. Both male dogs and female dogs can signal in the same way that they want to pee. Either they go to the garden door and look at you begging, I want to pee, or they go to the front door and they get hold of their leash and they show that to you, telling you, hey, I need to pee, my bladder is filled to capacity. So that's what both these dogs will probably do in the same way. Now, when we go to our male dog class, you see that it now has a squiggly line, which means that we need to tell it to override the P method in the base class. But why did we write that code then? Well, we wrote that so that we can call the method in the base class, like so. In this way, when you call the male dog method P, the first thing it will do is it will call the P method in the base class. That can be very useful. Now, in this particular example, that's not very impressive because it's just one line, but take, for example, a class called document base. And then within your organization, you have handfuls of documents that will actually want to inherit from that document base. You've got invoices, you've got letters, you've got quotations, you've got specifications, you've got brochures, whatever. And some of the code which is necessary to create an invoice or a quotation is the same for each document. So you can then use a virtual method in your base class, which does the things that are actually non-document specific. And then when you've done that, you can execute the stuff that is document specific, or in this case, dog specific. So that that in itself can save a lot of duplicated code in an overriding class. So let's do the same thing for the female dog. We are going to override the method in the base class. And the first thing we're going to do is we're going to call the base class. Now, When we do that, we should see a slight difference in behavior in that the dogs will now not just pee, but they will announce that they need to pee. Where's my here? Good. So, Fido now announces that he needs to pee, so we have the time to take him out or to let him into the garden where he will do his thing. And the same thing goes for Fifi, so that she doesn't have to pee in the living room. Good. We still have a problem though. You see, we are able to create a new dog. We'll call the boy Brutus. And we can create Brutus as if it is a dog base. So this would be a non-gender specific dog, and we don't have those, but we'll start off with that to demonstrate the problem that we have. Brutus, semicolon. Now we need to call the Brutus P method. Now let's see what happens. First of all, let's add a little separator here so that we can distinguish between the various bits of code. Let's add the same thing between Fido and Fifi. Good. Now, if we run this, we will see a problem popping up. And here is our problem. Oh, I need to hit F5 here. Let's get rid of this breakpoint. Boom. Now, where did it go? There. See, here's the thing. Fifi and Fido both managed to pee successfully, but Brutus has no implementation for the method pee, other than announcing that he actually needs to pee. This is because we have instantiated Brutus as a dog base class. You see, the gender non-specific version of the dog. And that's not what we want. What we want is that when we create a new dog, it has to be either a male dog or a female dog. Remember, we're working with the general concepts, not the outliers here. So, if we specify Brutus as a female dog, let's mess with the boy's head a little. We will see that we have successfully saved Brutus from the exploding bladder problem. He needs to pee, he squats, and he lets go. So much for his filled bladder. Of course, this is not entirely what we want. We want to enforce that when we create a new dog, we make it either a female dog or a male dog. And we can enforce that by specifying our dog base as an abstract class. When I now try to say create a new dog base, the compiler will slap me on the hand and say cannot create an instance of the abstract type or interface dog base. So I need to make a choice here. Is Brutus a male dog or a female dog? Well, let's resolve his identity crisis here and make him a male dog. So here we have the abstract keyword and what it does to a class. It's usually a good idea to determine at design time whether your class is going to be a base class or a derived class. Of course, technically, you can feel free to create a class that can service on its own, but that can also have other classes derived from it. But this is a design pattern that is generally considered as having a code smell. So usually what we do is we create a base class and we say, okay, this base class is abstract because we do not want anyone to use that class in itself. We can also create an abstract method. Let's do that for fun. So let's create a public abstract void bark. And let's create a parameter that tells us how often the dog should bark. So barks. It's an abstract class, which means the class itself has no implementation. So rather than giving it an implementation between curly braces, we just give it a semicolon and leave it at that. This does two things. The first one is evidence, and that is it enforces each deriving class to implement an inherited abstract member, bark. Right click, say refactor, implement abstract class, and now you can see that we have an override void bark method where we can say since it's a male dog, it's a manly wolf, like so. Now in the female dog we have of course the same issue because that one inherits from dog base as well, so it also needs to implement an abstract method called bark. And how do female dogs bark? Okay, dog people are going to object to this but because it's not true, but we will make our female dog say yip, like so. Why would you do that? I see you ask. Why would you even bother to create an abstract method that does nothing if you're going to have to implement it as an override method in the derived class anyway? Well, there's two reasons. The first one is when you create a derived class from dogbase, you tell the derived class, hey, you need to implement a method bark. The second advantage is a little less obvious, but we're going to demonstrate that anyway. You see, all our dogs, whether they are male or female, share a common type, and that's the type of the base class. So what we could do at this stage is have a list of type dog base. Dog pack equals, list of type dog base, and here we have it. Normally, you would not create all your dogs by hand in the code. You would read them from a database table or something like that and put the results in a list. But since we create them manually here, we will have to add them to the list manually. Dog pack. Add Fido. Like so. We do the same thing for Fifi. Dog pack. Add Fifi. And while we're here, we have Brutus anyway, so let's add Brutus to the dog pack as well. Yeah, indeed. Brutus. Like so. Now we have all our dogs in a dog pack. What if we want to make all the dogs bark? Well, the dog base class has a method to make the dog bark. Now, it is an abstract method, but it is available in the dog base class. So, when a dog is added to the dog base list and we call the bark method on that particular instance of dog base, it will jump to the abstract void bark method, and then it will be able to pick the override method from there. So let's go to our program and let's assume that the postman comes. Now dogs always bark when the postman comes, so first of all let's make the postman well ring, and the postman always rings twice. Ha ha ha. Because he rings twice, the dogs know, oh, that's the postman. Now, all of them will want or will have to bark. So we could do a for each var d in dog pack, which contains the male and the female dogs, d dot bark. And we have a bark method available in the base class. So if a d is in dog pack, which is a list of type dog base, then the bark method will be available. And we can specify that they all need to bark 5 times. Now, let's see if we need to add anything to the female dog and the male dog class to make it bark 5 times. Yes, we need to do something here. For e equals 0, int e of course, like so. I should be smaller than barks because it's 0 based, and b plus plus, like so, and like so. Now that should do the trick. Don't know why there's a squiggly line here. Yeah, that'll probably disappear when yes, I'm missing a bracket, like so. That should fix it. Okay, now let's go to the female dog, which has to say yep for barks times. So for e int e equals 0, I smaller than 5, I plus plus, and like so, and like so. Now, both the male dog and the female dog, since they both inherit the dog base class, will get this method called if we call it through the list of type dog base. So let's go to program. Let's see if this actually works. That should do the trick. Clickety click. It's building. Look at that. Okay, here we see the postman ring, 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 and each of the dogs now barks 5 times. Now, of course, when you have only 3 dogs, we are not saving an incredible number of lines of code here, but we've got it structurally right. And if the code to bark would be a lot more complex, then we would actually have saved ourselves a lot of effort here. So that wraps up what I wanted to do with this particular demonstrator, we are going to play around with some other stuff. We have been working with the concept of the hierarchical inheritance model, but we also mentioned the multi-level inheritance model. We have some time left because we have fulfilled all the requirements that the product owner had, and we've been fornicating about with some other stuff as well on top of that, so we might as well continue that. Um, let's see. Dogs are mammals. There are lots of other mammals, but we have created a mammal. Now, is there something that all mammals do? Yes, they breathe. You might argue that a fish breathes as well, but a fish gets its oxygen from the water through its gills. So it's not having anything considered to be a lung. All mammals, however, breathe through their lungs. So if we would create a, oh come on, add a new class, which we call mammal base, because it's a base class, we can use that mammal base class to make our dog and our cats breathe. Public, like so. Now, do mammals all need names? Yeah, I don't know of many people who has a sperm whale as a pet, and they're also usually not come across in dolphinariums or zoos or whatever. So let's assume that a mammal doesn't need a name. So we can leave that one out, but we can introduce a public void breathe method. And the breathe method is quite simple. It consists of inhaling and exhaling, like so. Now, if we make our dog base class inherit from mammal base, what this means is everything that is available in the mammal base class, every public method available there, and also any properties that you might want to add, are also available to the class that inherits it, which is dog base. And this means that everything that's available to dog base is also available to its derived classes. So without changing anything in the male dog class or the female dog class, we should be able to make our dogs breathe. See? Like so. Now let's add a little separator here again. So you come here and you join us there. And let's see if this actually works. No, there were build errors. Yes, well, that's quite a simple one actually. I'm just missing a semicolon here. So let's add that and try again. And here we have it. There is no breathing going on. Why is there no breathing going on? Let's check. We put a breakpoint here. Rooters breathe. It goes straight to the mammal base class, so that's what we want. It does a console write line, and it should have breathed, and if it doesn't, there's something going on which I do not understand. Which, oh, hang on a second. Hang on a second. I'm making it breathe before I'm making them all bark. So I was looking at the wrong place. I also see a little bug here. It says inhale and exhaling. So we have a bug here, which we normally should have had to fix 3 times if it weren't for base classes. But now the bug is exactly where it belongs. So we can fix it in one go. And do that again. And for some reason, it's now exactly where we want it to be, namely on this screen. And after Brutus has peed, he has inhaled and he has exhaled. So, multi-level inheritance allows us to make a base class inherit from a higher base class, which automatically makes the method in the base class here through dog base, which inherits it, available to male dog and female dog without each of those dogs having to have an implementation of the method breathe. They get it through their base class from the base class at the top level. So, do all mammals walk? Nope. Our sperm whale, not being a land dweller, will have a very hard time doing so, and if it even tries, it will all end in tears. So at this point, we are tempted to create a base class of animals that can walk. Would that be vertebrates? No, because there's many vertebrates who cannot walk. A sperm whale is a good example. So we will have to make a class called land dwellers or something like that. And we could have our dog class inherit that base class as well. But then we are doing multiple inheritance. And as we said in the PowerPoint presentation, we are not going to do inheritance because it potentially sucks. So, how to crack this then? Well, that's what we have interfaces for. But that's the subject for the next installment. So we're not going to do that here, otherwise I'll be talking for the next hour or so. So, this wraps it up for the demonstration. I guess this is a good time to say that I'll have to remind myself to add a link to the repository where this code will be stored so that you can take a look at it later on. Maybe you've been following this along with me and there's something that you can't figure out. You can take a look at the repository and the solution that is in there yourself, or you could just put me a question either in the comments down there or maybe even in email. And I'll have to remind myself that I will put the email address in the comments below as well, or in the description, that is. So, thank you for watching so far. And I will, if you subscribe, I will be able to let you know when the bit about interfaces has come online. This will probably take some time because it's quite a subject. So don't expect that tomorrow or maybe not even this week, but it will happen. There's always next weekend. So I'll stop talking now, I promise. Thanks for watching so far. And if you liked it, please hit the like button. Okay? Cheers. Bye.